the beginning of this series, I gave a challenge: how to take the average of 10 million numbers. We tried to load that file into Excel. It didn't work because Excel can only accept just over a little bit over 1 million numbers. And so it was the problem that off-the-shelf technology couldn't do. Can we do this using code? The program we're going to do in this video meets that challenge. We're going to be able to take the average of 10 million numbers, and it's going to take a couple seconds to run. The first step in doing this is go to your average_argv folder. The program we're going to write is very similar to average_argv. So you make a copy of that, and then you rename it average_big for big data files. Then you go into that folder, you delete the executable, and you change the program average_argv.c to average_big.c. We need to do one other thing. We need to add big data files, and so I go back into my data directory and I copy o1m.txt, that's the 1 million data point file, and o10m.txt, 10 million data points. So I put those into the same folder. Then I double click on average_big.c, and it should come up in Xcode no problem. The main change that we have to do with this program is we need to change the data types that we selected. Before we had ints and floats, but there actually is a size limitation to ints and floats. This is a computational science issue. Computational science, not computer science, is a field of study, and it's how to make big calculations, how to use computers to do big calculations. And so the type of data file, there are limits to this. For example, an int can only be from about -32,000 to +32,000. And there are limits on floating point numbers. How many points after the decimal place can you have? So these are limited. So there are ways to make those variables bigger, and that's to change their names. So instead of using floats for this program, we're going to use doubles, D-O-U-B-L-E, doubles. And that gives us enough flexibility to be able to do all the floating point calculations with doubles. As an aside, many computational scientists just say always use doubles, not floats. I think that's probably a little excessive sometimes. For very simple calculations, you don't need it. But it is good advice in general is to use doubles, not floats. Now, to change integers, we need to make it a long int, long space int. And long ints can be from about -2 billion to +2 billion. In the field of computational science, there's all sorts of things you can do. You can make them unsigned long ints, and so it goes from 0 to 4 billion instead of -2 billion to +2 billion because we're only counting up in numbers. There's tons of different tricks you can use, and the reason I bring all this up is not to sort of distract you from the task at hand, which is making this program, but it's just to expose you to the field of computational science. It's a thing. It is a field of study. It's a scholarship. Mathematicians, some engineers and scientists do it. So it's not uncommon especially in research. All right, so we changed all our ints to long ints. We changed all our floats to doubles. It has an impact in the percent characters that we use in scanf and printf statements. I'm going to talk about that later. The other thing is that we could store 10 million, as we load up a data file, we could store 10 million data points in an array inside our program. But and that's actually not too big, but at some point it's going to get to the point where you're going to get to a file that's way bigger than a C program can handle, that the memory of your laptop, of your computer can handle. That's also a field of computational science as well as memory management and all that stuff. We don't really need to store the array. We don't need to store all those points in an array. We need to use each data point once to add to a sum and then throw it away. And so what I've done here is I've replaced float a brackets 1000 with a double temp, TMP, just a temporary variable. We're just going to use it once each time through the loop. That's it. And so this way we don't have to store all the data in our working memory. The C program doesn't have to store all the data in the working memory. Memory management is another area of software engineering and computer engineering and stuff like that. So knowing how much memory your program uses is also a thing. This doesn't use much memory because we're only storing one data point at a time, and we're just writing over it each time. Good? Okay. So in order to do that, in order to be able to use this temporary variable, we have to take, in the other program, we had two loops. We had the while loop to scan all the data in, and then we had a for loop below to do all the summing calculations. We're going to merge those into one. So there's only one while loop here. Before that while loop, you have to set sum equal to 0. And then inside the while loop, before the I++ statement, I'm going to say sum equals sum plus temp. So the first time through, the very first number in the file gets added to sum. The second time through, the temp gets rewritten and the second number gets rewritten into temp, and then the second number is added into sum, and so on. Temp will store, at the end, temp will just have the last value of the file in it. So that's how this temp works. For big data files, it's a useful trick to be able to do that all the time. We're going to go into that a little bit more in future videos. That's it. That's the changes. 2 loops to 1, change all the ints to long ints, change all the floats to doubles. The last thing they have to change in this program is you have to make sure all your percent characters are right. So in the fscanf statement, you need to use %lg for long floating point wildcard variable. And then in the printf statement for the integer n, you have to say ld for long decimal and lf for long float in %ld and %lf in your printf statement to make sure that the type of percent character matches the variable that you have. If you don't, it'll get you an error. If you don't do that, you'll get errors. That's it. I think that's all you need to do to change this program. So we save it, Command S. I go into terminal. I click on the terminal icon. It comes up. I cd desktop, cdc code, cd average_big. And then I'm going to just compile the program and run it. Now, the first time I'm going to run it, I'm going to run it with a small data file. So I do /average_big space o10.txt, and it works. It gives me the same answer as before when we did this before. Then I don't recompile it or anything. I just go /average_big o1m.txt to do the 1 million data point file. Boom, it does it just like that, super fast. And then I do the line again, /average_big space o10m.txt. And it takes, with a Mac, it takes 2 seconds. So when on my MacBook Air, it's an old MacBook Air, it took 2 seconds. So after 2 seconds, the answer comes up. This task that just happened on the screen was impossible with off-the-shelf tools like Excel. Couldn't do it at all. Here, it wasn't too hard. And I'm going to make the argument that it didn't take us very long to get to this milestone. We did learn a lot on the way. We learned a lot of stuff in the preceding videos here, but it didn't take us that many videos to get to be able to achieve taking the average of 10 million or even more, 1 billion numbers. This algorithm would work with 1 billion numbers no problem. It just takes time, that's all. So I hope that this convinces you that learning how to code in C and programming in general is an extraordinarily valuable tool. This is the end of me doing a sales pitch for programming. It should be obvious by seeing this example that it can help you do really, really big things that you just can't do with other tools. The subsequent videos later in this series are just going to give us even more tools to become yet even a more powerful programmer.